Okay, example 4. Finding equations of lines that are parallel and perpendicular to a given line. And here's the given line. Passing through a given point, and the given point is negative 4, 1. So a lot of times you'll see a line, the equation of a line given as our example, 5x minus 3y equals 8. So first thing you want to do is just put it in the slope-intercept form. So we want to solve for y. So let's just rearrange some stuff. So 5x minus 8 equals 3y. Now what we want to do is divide everything by 3. So 5 thirds x minus 8 thirds equals y. So this is our equation. Leave it in fractions because we know that 5/8 now is our slope. And so what I would suggest at this point is let's go ahead and graph it and see what it looks like. So I'm going to draw a coordinate system. Hopefully this graph is out of the way enough. So now we want to plot, well, let's just do an XY table. So we'll do it right here. When x, and this is the equation that we're going to use. Let me write it again. Y equals 5 thirds x minus 8 thirds. So this is what we're going to graph. So when x is 0, y is negative 8 thirds. We can get another point. Let's go ahead and graph this first. So when x is 0, make it in red. X is 0, y is negative 8 thirds. That's a little bit less than 3. So I'm just going to put my dot there. Now, I can either find another point, or since I already know my slope, I can just use the slope and get the second point. So the slope is 5 thirds. So if I go up 5 and over 3, so here's 1, 2, 3, 4, 5, and over 3. Looks like my second point is going to be right about there. So let me draw the first line. And remember, you want to do this with a straight edge. So I'm going to draw it. Make it so there. So that's pretty close. Now, our other point is negative 4, 1. So I'm going to put that point in. 1, 2, 3, 4, 1. Negative 4, 1 is right here. And so what we're trying to find is, I'm not going to do this exactly, but we're going to try and find a line, equation line that is parallel and perpendicular to the red line. So if I just sketched in a parallel line, kind of like that, and we're going to call this y parallel. And then I'm going to sketch in a perpendicular line, be kind of something like this, and we're going to call this y perpendicular. Now, I just sketched those. I didn't do them really accurate, but I just wanted to give you an idea of what we're trying to find. So let's go ahead and solve for y perpendicular first. And we're going to use the point slope equation. So y is equal to m times x minus x1 plus y1. So for the x1 and y1, we're going to use the given point that was given. And we know the slope is 5 thirds, so let's just write it out. The equation says 5 thirds times x minus x1 is a negative 4, so this makes it x plus 4, plus y1 is 1. So now all we have to do is clean this up a little bit. So 5 thirds x plus 5 thirds times 4 is 20 thirds. Notice I'm keeping everything in fractions because a lot of times you'll have answers in fractions. So now I'm going to, instead of adding 1, I'm just going to add 3 thirds. So finally it's 5 thirds x plus 23 over 3. And that is y perpendicular, or sorry, y parallel Put a box around the answer. And now we can solve y perpendicular. Well, first of all, let's go ahead and write the equation. Y perpendicular is going to be the same. M times x minus x1 plus y1. But our m in this case, the perpendicular m, is going to be the negative reciprocal of 5/3. So it's going to be negative 3/5. We're going to use the same point, negative 4, 1. So negative 3/5 times x minus y1, or x1 is a negative 4, minus a negative 4, so plus 4, plus y1 is 1. Okay, so now negative 3/5 x is going to be minus 3/5 times 4 is minus 12/5, plus 1 is 5/5. And finally, we have negative 3/5 x minus 12/5 plus 5/5 is minus 7/5. That is y perpendicular. Put a box around the answer, and you're done. Okay, example 5. This is a word problem. So you're driving down a mountain road. Driving down a mountain road. This is assuming you have your driver's license. Some of you don't have it yet, but we'll soon get it, I think. Okay, there's a sign that says 9% grade, pretty steep grade, for the next 2 miles. Question is, how many feet will you descend? How many feet will you descend? Okay, so here's how we set up a problem like this. First we know, well, the sign says a 9% grade. So that, and since it's going down, that means we have a negative slope. So if we wanted to kind of draw what that's going to look like, let's say here's the road, and let's say this isn't going to be to scale. Well, let's say I just draw in a negative slope. Let's say it's like that. And we know that it's m is equal to 9%. Well, except that it's going down. So since it's negative, m is equal to a negative 9%, but we don't want percentages, we want decimals. So it's equal to a negative 0.09. Okay, and we're trying to find delta y. It's how far you're going to go down. So we want this distance here, delta y. So delta y, change in y, is equal to a question mark. We don't know. Well, delta x, we already know what delta x is. This is the x dimension here. And it says 2 miles is where you're going down. And so this is equal to 2 miles. But the question says how many feet? So this has to be 2 times 5280 feet, because we're just going to change it into feet. So now, let's fill this in, 2 times 5280 feet. If you didn't know that there's 5,280 feet in a mile, you could look it up. So now all we have to do is put it into our equation. We know that our equation is m equals delta y over delta x. So we want to solve for delta y. So delta y equals m delta x. M is 0.09 and delta x is 2 times 5280 feet. So then if you just put that into your calculator, you'll end up with a negative 950 feet. So that's how far you will descend in height when you go 2 miles on this 9% grade road. Okay, the last example, example 6. This is about buying a car and figuring out a straight line depreciation, coming up with an equation for the line. So straight line depreciation, which means you're going to have a line with a negative slope. Straight line depreciation. Okay, here's what's given in the problem. You're going to buy a car for $25,290. And you're going to, so that's to buy a car. And you're going to replace the car after 11 years. So you're going to keep it for 11 years and you will sell it for $1,200. This is I would say it's a pretty good real life estimation. So what we want to do is write a linear equation for the straight line depreciation line. So let's first just draw and see what this is going to look like on a graph. So we'll start off with our graph. And this doesn't have to be the scale, but this is going to be time on the x-axis, and this is going to be dollars on the y-axis. So at time 0, you are buying this car, and you're buying it for $25,290. Now, you don't have to scale these kind of problems. We'll just call this $25,290. And the other thing you know is after 11 years, and again, it doesn't have to be right to scale, but you're going to sell it for $1,200. So let's say here's 11 years, and this is $1,200 right here. So this is 11, and this is time 0. So we have our 2 points. Let's draw a line, just so we know what it looks like. So, whoops. Erased it, so yeah. Okay, so let's say this is our line. Now what we need is the 2 points. Well, this point is 0, 25 to 90. This point is 11, 1,200. And we'll call our line, we'll call it V. For the equation, we're going to use a point-slope equation, but we first have to get the slope. You have 2 points. First thing you need to do is get the slope. So slope is delta y over delta x, which is, here we're going to call, let's call this 0.2. And this 0.1. It doesn't matter, really, but I typically, I'd call this 0.2 because it's farther to the right than 0.1. So you can do it either way, it doesn't really matter. So delta y is going to be 1200 minus 25,290 over 11 minus 0. Now, this is going to give you a negative answer, which you expect because it's a negative slope. This is going to give us a negative 2190. So this is m. Now, we can use our point slope equation, v equal to m times x minus x1 plus y1. Now, also, you can use either point for the x1, y1. And so, since I started out with point 1 being on the left, I'll just keep it at that. Doesn't really matter. So, m is negative 2190 times x minus 0 plus y1 25,290. So it's equal to minus 2190x plus 25,290. That's v. Now, the other thing we have to identify, once we find the answer, we want to specify the domain. Because if we were to say, after, say, 14 years, well, that's past the domain. And so problems like this, we have to specify the domain, which is between 0 and 11 years. And that's the domain. So this actually becomes part of the answer. Okay, that is it for 1.3. And as always, homework will be in Google Classroom.